Hello everyone, I welcome you all to Dr. Ray class. We have a problem here. Let's try and solve it together the simplest and easiest way possible. The question is this: an object is placed 60 cm in front of a concave mirror and a real image is produced 20 cm from the mirror. Question A: what is the magnification produced? Question B: what magnification will be produced if the object is placed 20 cm from the mirror? To make this question easier and clearer to understand, make a rough sketch describing the values given to you, and that I have done over here. Now, looking at this my rough sketch, I captured that the mirror is a concave mirror. That means the background is the reflecting surface, and this is the plane surface from where the light comes. I've drawn my principal axis cutting the mirror at the pole. So this my horizontal axis. What will I use it to do? From this pole, any horizontal distance to my left is negative. Any horizontal distance to my right is positive. Through the pole again, I will draw a vertical line. Any distance above P is positive. Any distance below P is negative vertical distance. So we're going to use this convention now to analyze this problem. Now look at this. The object is placed 60 cm in front of the concave mirror. So this is the front of the mirror, this is the back. I take this position as where the object O was placed, 60 cm from the mirror in front. And if you remember, for a concave mirror, the real images are always formed in front of the mirror. So that means this our object, which we are told had a real image, was formed in front of the mirror. And where was it formed? 20 cm from the mirror. Object is here 60. Look at image I at 20 cm from the mirror. I use my understanding that the image should be inverted to draw it inverted. Let's assume you don't know, you can equally draw it standing, but you know it's not possible for a concave mirror to form an upright image at the front. Even if you draw it up standing, when you solve, the sign will come out and tell you that wasn't the correct way, and you are going to see how that will work. Now, what is the first thing I want you to learn from this? My EU. Remember I told you any horizontal distance to the left is negative. I will put minus 60 cm. Image distance V, equally in front of the mirror to the left of the x-axis, so it has to be minus 20. Remember, I'm using this sign convention so that you understand what is happening. Now, question A is asking the magnification. It is minus V over U. Now let's substitute gently. See, I put this minus because I'm using the sign convention. What is my image distance? Minus 20, because minus it is in front of the mirror, over object distance minus 60 because it was in front. Minus times minus is plus 20 over minus 60. This will give you, minus will cancel, 2 here 1, 2 here 3, minus 1 over 3. The same thing as minus 0.33. This is the magnification, telling us the size of the image is smaller than the size of the object because it is less than 1. The minus is telling us that while the object is standing up, the image is standing in the opposite direction. That's the meaning of this minus. Now we've solved the A part. Let's go back to the question and solve the B part. Now, to solve this B, don't rush and say, oh, the second condition said if I change the position of the object to 20, I get as my V, you now go and say M is equal to minus D over U. This is actually a wrong concept, because it's not true for you to just come and say magnification is inversely proportional to 1 over U. It's not appropriate. There is something about this mirror we've not found out. What is that? We don't even know the focal length of this concave mirror. Now, for this B part, we still remember that U is in front of the mirror minus 20 because it is in front. Okay? How can we find the focal length of this mirror? Let's use the condition in A. From U equal to minus 60, V equal to minus 20. Let's find the focal length of the mirror, which is constant. Remember the mirror formula, 1 over F equal to 1 over V plus 1 over U. So if we substitute these values, we'll have 1 over V is minus 20 plus 1 over U is minus 60. So 1 over F is equal to, take LCM, 60. 20 divided 60 is 3. 3 times minus 1 is minus 3. Plus 60 divided itself, 1. 1 times minus 1 is minus 1. So this is minus 4 over 60, because minus 3 plus minus 1 is minus 3 minus 1, which is minus 4. So to get F, you invert this, meaning you are going to invert this. So this becomes minus 60 over 4. So our frequency is minus 4 divide itself, 1 divide 6, 1 remainder 2, divide 20, 5. So frequency, focal length is minus 15 cm, minus telling us it is in front of the mirror, which is true. Now we can use this F and this U to find the new magnification. For you to even find the new magnification, you need to find the new V. So using the mirror formula, we still see that this is U over V. Now we know that our F is minus 15 equal to 1 over, our new U is minus 20 plus the new V we do not know. No, I want to make V the subject, so I will remove this part of the term to this side, collecting like terms. I have 1 over minus 15, minus crossing over becomes plus 20 equal to 1 over V. When you take LCM here, this is 60. This divided by 60 divided by 15 is 4 times minus 1, minus 4, plus 20 divided by 60 divided by 20 rather is 3. 3 times 1, 3, equal to 1 over V. So we have minus 1 over 60 equal to 1 over V. Therefore, the new image distance, when the object distance is 20, is going to be minus 60 cm.